Okay, here we go. We're going to look at formulas and equations. Our goals are to evaluate a formula, solve for a variable in a formula or equation, solve applications of linear equations in one variable, and then solve applications using proportions. So formulas are used in a lot of applications, and most of them that we'll be studying in this course are in finance. So this could be interest earned on investments, in your savings account, interest charged on a loan or a credit card, things like that. And understanding how to use these formulas will let us make better decisions for ourselves because we'll be able to calculate which offer is best for us. Here's our first definitions. Evaluating formulas is going to involve a formula, which is an equation that typically has a real-life application. Like I said, in terms of finance, we can apply it to our lives. To evaluate a formula, we substitute given values into the variables and then use order of operations to find that value. So this is where we're plugging in values for time, maybe the length of time we hold an account, and find out how much we're going to earn, things like that. So Brano invests $1,500 in a certificate of deposit, a CD, and it pays 1.5% simple interest for 2 years. The simple interest formula is used to calculate the interest earned on the investment. The simple interest formula, I equals P times R times T. And that is principal times rate times time. Determine the simple interest that he'll earn on the CD. So we want to calculate the simple interest. We want to know what is I. I always start by writing our formula and then filling in everything that we know to find out what we don't know. We want I. That means I stays I. Everything else we should be able to plug in. Principals first. Principal is our starting amount. So in this case, since he invested $1,500, that's our starting amount. R is the rate. We just look for what is our interest rate. In this case, it's 1.5%. In order to use this percent in our formula, it has to be in decimal form. So we're going to move that decimal 2 places and then fill in with zeros. So we're going to have 0.015. Excuse me. Now that it's in decimal form, we can use it in our formula, 0.015. Last is the time. In finance in general, we'll be using time in years. This one already gives it to us in years, so we don't have to change anything. We just put a 2. But beware, if they give you something and it's not in years, we want it in years when we're dealing with finance situations. For example, if they say 6 months, that would be 1/2, half of the year. Okay, now we multiply all of these things. So we'll have 1,500 times 0.015 times 2, and we get out 45. Now, because they gave this question to us in sentences, we should answer with a sentence. So this calculated the interest. So we would say the interest that Brano earns on the CD is $45. And that will be our answer. Now, dealing with this same situation, what's the total value, including the interest, that he will have after those 2 years? Well, since we calculated that his interest earned was $45. Is that how much he'll have after 2 years total? No, it's not, because we still have to account for the money that he has in there already. He already put in $1,500. He just earned $45 more. So we take the amount that he had, we add what he earned in interest, and that will give us the total. That's what he has in total at the end of 2 years. So our sentence would be, he has $1,545 after 2 years. Okay, let's look at another one. The volume of a rectangular solid can be determined using the formula V equals length times width times height. Use this formula to determine the width of a rectangular box of ice cream if the length is 7, the height is 3.5, and the volume is 122.5. Again, start with your formula, V equals length times width times height. Plug in what you know, and then solve for what you don't know. So we know the volume, 122.5 equals, we know the length, 7. We don't know the W, the width. So I'm going to leave it as a W. And we know the height is 3.5. So now we'll use those properties that we talked about last time and get W all by itself. So I'm going to divide by 7, I'm going to divide by 3.5, and whatever I do to one side, I have to do to the other. Now in this case, you can do divided by 7, and then whatever that comes out to be divided by 3.5. You can do it in 2 steps, you can do it in 1 step, just as long as you're doing your math correctly. So 122.5 divided by 7 divided by 3.5, that leaves us with a width of 5. So our sentence would be, the width of the ice cream box is 5 inches. Now, all of these situations are using mathematical models. That is a formula or an equation, or maybe several equations in some cases, that represent a real-life situation. So volume represented by length times width times height. That's a mathematical model. If you come across a problem and it says, create a model for this situation, it's asking you to make an equation. Sometimes we might see something called a subscript, and that's when you see a little tiny number after the variable. And those are just clarifying that the variables, even though they might both be x's or they might both be a y, if it's a y sub 1 or a y sub 2, that means those y's are not the same value. Okay, so it's just differentiating between different variables. This next example, I'll show you what I mean. Slope, we know as m, uses the formula y2 minus y1 over x2 minus x1, where the coordinates of 2 points on the line are x1, y1, and x2, y2. So we know that x1 and x2 represent 2 different x's on the graph. y1 and y2 represent 2 different y's. Use this formula to determine the slope of a line containing the points 3, -2 and -1, 6. So I'm going to make this point 1 and this point 2. And knowing that a point is written x, y, now I know which one is going to be x1, which one's going to be y1, and then which one's going to be x2 and y2. So let's start with our formula. y2 minus y1 over x2 minus x1. We want to fill it in. So y2, x, y, is 6 minus y1 is -2 x2 is negative 1 minus x1 is 3. 6 minus negative 2 becomes a 6 plus 2, so we have 8. Negative 1 minus 3 is negative 4, so we'll have negative 2. Our sentence will be the slope of the line containing these 2 points is negative 2. Now we'll practice isolating a variable. Here we want to solve the equation 2x plus 5y equals 0, and we want to solve it for y. That means we want to get y all by itself. So the first thing we'll do is work the furthest away from the y, working our way in. We will want to move 2x first. So we'll do the opposite, which is subtract, and whatever I do on one side, I have to do the other. So we'll be left with 5y equals negative 2x. Now I have 5 times y on one side. I want y all by itself, so I'm going to divide that 5 away. And whatever I do on one side, I have to do on the other. Now I have y equals negative 2x over 5, or 2/5 x. But we have y on one side, everything else on the other. And we're done. This example is important from statistics, and it calculates something called the standard score, or the z-score. Z equals x minus mu over delta, maybe? Sigma? What I don't want you to do on this is to freak out. Treat all of these symbols as if they were variables. We are solving for x. That means all I want to do is move everything away so I have x equals everything else. So, since everything is being divided by the sigma, I'm going to multiply it to move it to the other side. If I multiply on one side, I have to multiply by the same thing on the other. Now I have sigma z equals x minus mu. X is still not by itself, so I'm going to do one more step and add to move that to the other side, just like we've done before. Now we have x is sigma z plus mu. And really, you can call them whatever you want. You can say, okay, I'm going to multiply by the cherries and move it to the other side. But whatever I do on one side, I have to do the same thing on the other, okay? All we did here is isolate x. It could be any symbols, any pictures, as long as you do the same thing on one side that you do on the other. Here, we have a formula to represent a linear equation called slope-intercept form, y equals mx plus b. It might be familiar to you. Let's solve this equation for m. So we are isolating the m, moving everything else to the other side. Let's start farthest away from the x, or farthest away from the m, and move our way in. B is being added, so let's subtract it. Now we have y minus b equals m times x. From here, we just have to divide the x away. Divide x, and whatever I do on one side, I have to do on the other. M equals y minus b over x. Now I have m on one side and everything else on the other. That's our goal here. Now, as we move forward, it's going to be very important for you to be able to recognize algebraic words and phrases. That way we can translate it into symbols, a lot like we did for logic. But in this case, we're using words that we have known before. Things like more than, increased by, we know our addition. Less than, decreased by, we know our subtraction. Twice a number, the word product, tell us multiply. Quotient, divided by, those tell us to divide. The ones on this list that are most frequently kind of mixed up, I would say, is if I have 4 less than a number, 3 decreased by a number, those ones usually get mixed up. So make sure that you pay attention. 4 less than a number means I'm starting with a number I don't know and it's 4 less than, so it's x minus 4. 3 decreased by a number means I'm starting with 3 and decreasing it by a number I don't know, minus the x. So the order on those is really important. Make sure that you are taking it slow on the subtraction word problems to decipher them correctly. Here are some more important phrases. These ones are adding in 2 steps into one phrase. 4 less than 3 times a number. So now we see I have 3 times a number and I'm subtracting 4. 10 more than twice a number. Now here I see I have twice a number, 2 times a number, and then I'm adding 10. So we can see these phrases can become more complex, and that's where it takes a little bit more time. Don't try to rush these. Take your time, decipher them, and then double check and triple check to make sure that you got it the right way you want to work with it. Because once we translate our phrases into mathematical expressions, that's when we're going to start solving. So we want to make sure that this very first step we have correct. Here are some more phrases, and the one piece, the one word here that I want to highlight is. The word is in mathematics always translates into an equal sign. So every time you see the word is in a word problem, you want to think, okay, I'm going to put an equal sign here. That turns our expression into an equation. Okay? If you remember from week 1, we went through problem-solving procedure. This is a recap of that because the same procedure applies to solving word problems. So we're going to bring that back from week 1 and use it in chapter 6 and 7 so that way we can translate and solve these word problems. Go ahead and pause here so that way you can write these down. Now let's work through a few. Jana purchased a copier for $2,300. The cost to make each copy is 2 cents. If Jana spends a total of $2,626 in a year, which includes the cost of the copier and the copies made, determine the number of copies she made. Let's break this down. We know that the total cost here is made up of the copier and the copies put together. So if we know the cost of the copier and we add that to the cost of the copies, we will have the total cost. It tells us that the total she spent was $2,626. So that's our total cost. We'll fill that in, $2,626. We also are given the cost of the copy machine, $2,300. So we can put that in, $2,300. And then we have the cost of each copy, 2 cents for every copy. So we'll put 0.02 multiplied by however many copies. We'll put a C. We don't know how many copies, that's what we're looking for. Now that we've translated this into an equation, we can solve for the copies. Let's subtract 2,300. Whatever we do on one side, we have to do on the other. We will be left with 326 equals that 2 cents per copy. Now here you want to be careful because you might be tempted to multiply by 2 cents. But look here, we have 0.02 times C. To get C alone, we do the opposite, 0.02. We're dividing it away. And whatever I do to one side, I have to do to the other. So in your calculator, you should be typing 326 divided by 0.02. This tells us that C is 16,300. Okay, again, we were given this problem in sentences, so we answer in sentences. Jana made 16,300 copies over the span of a year. Something like that. Okay, here we have Casey making some punch. Casey needs to make 2 gallons, which is 256 ounces of punch for the party. Her recipe requires mixing pineapple juice, ginger ale, and orange juice. The amount of ginger ale required is twice the amount of pineapple juice, and the amount of orange juice required is 5 times the amount of pineapple juice. How many ounces of pineapple juice, ginger ale, and orange juice should Casey mix together to make the punch? Now this is where our translating skills come into play. Go ahead and pause and try it, and then we'll go over it. So, we know that the punch is made of pineapple juice, ginger ale, and orange juice put together. I'm going to represent the pineapple with a P and the ginger ale with a G and the orange with O. So, she wants a total of 256 ounces. That's all of the punch. So we'll put that here. 256. All 256 ounces are the combination of all 3 juices. So this tells us the ginger ale is twice the amount of pineapple juice. So for ginger ale, we'll put twice the amount of pineapple, 2 times P. Orange juice is 5 times the amount of pineapple juice. So for orange juice, 5 times P. And then the pineapple juice we said was represented with a P. Now, it should be pretty apparent we have P plus 2P plus 5P, all like terms, which makes it really nice for us because now we can add them together. 256 equals 5 plus 2 plus 1, 8P. Let's isolate P. We divide by 8, and whatever we do on one side, we have to do on the other. And so we should be plugging in 256 divided by 8, which gives us 32 for P. That means pineapple juice, 32 ounces. From here, we want how many ounces of ginger ale? Well, the ginger ale was 2P, so 2 times the pineapple juice. 2 times 32, 64. And then the orange juice, 5 times the pineapple juice. 5 times 32. 160. And now we have broken down each of the juices. Casey should mix together 32 ounces of pineapple juice, 64 ounces of ginger ale, and 160 ounces of orange juice. Okay, here we have the dimensions of a sandbox. Javier is building a rectangular sandbox for his children. He has 34 feet of wood to use for the perimeter of the sandbox. What should be the dimensions of the sandbox if he wants the length to be 3 feet greater than the width? Let's draw a picture. We have our sandbox. And let's recall, perimeter is when we add length plus width plus length plus width, right? Here we have our length, here we have our width. If we make all the way around the box, we've added the width, the length, the width, the length. We've gone all the way around. Now, for this specific box, he wants the dimensions, the length to be 3 feet greater than the width. So how would we represent that? The length is 3 feet greater than the width, which means we'll take whatever the width is and add 3 feet. Now it says that he has 34 feet of wood to use total, so that's our total perimeter, 34. The length, we're going to write as W plus 3 plus the W we already had, plus length is W plus 3 plus the W we already had. Again, we can combine like terms. 1, 2, 3, 4 W's. And then we have 1, 2 constants, so 3 plus 3 is 6. Now we're going to work on isolating that W. So we will subtract 6, and whatever we do on one side, we have to do to the other. 4W equals 28. Then we divide by 4, and we are left with W equals 7. So our width is 7 feet. That means our length, because it has to be 3 feet greater, is going to be 7 plus 3, 10 feet. So our sentence would be, Javier would build the sandbox with dimensions of 7 feet by 10 feet. Here's another example that you can work on your own if you would like. I want to cover proportions. So a ratio, oh, that's a mistake, not a statement of equality. A ratio compares two quantities. I want you to think of the ratio miles per hour. We are comparing miles and hours, so we compare two quantities in a ratio. A proportion is when we put two ratios equal to each other. And that's what we use to solve a missing piece in our ratio. So if you remember, cross multiplication, we have one ratio equal to another ratio. Then we cross multiply, A times D equals B times C, and then we can solve at that point. That's what we're going to be using today. Here is a procedure for solving proportions that you can pause and write down or read through, but I want to cover this example here. The cost for water in the city is $2.14 per 1,000 gallons of water. What is the bill if 25,000 gallons of water are used? So here we have dollars per gallons. That's our ratio. That tells us how to set them up, dollars per gallons. So we will have $2.14 per 1,000 gallons. Where you're using a proportion, so it needs to be the same on the other side of the equals. dollars per gallon. Since we're trying to find out what is the bill, we don't know the dollars. I'll just use X. We know the gallons though, 25,000. Now we use our cross multiplication to solve. So we'll do 1,000 times X and $2.14 times 25,000. 53,500. Get X alone, divide by 1,000, leaving us with 53.5. So we can say the bill is $53.50. Here's our last example. Insulin comes in vials with the number of insulin units per cubic centimeter, per cc. An insulin vial labeled U40 has 40 insulin units per cc of fluid. Tyler's insulin dose is 30 insulin units. How many cc's are needed for Tyler's dose? So it tells us, set it up, number of insulin units per cc. So our insulin units per cc is how we're going to set up our ratios. It tells us U40 has 40 units per cc. So 40 units per 1 cc. Tyler's dosage is 30 units. How many cc's? We don't know cc's. I'll use X. We're using 30 units. So now we have 40x equals 30. If we divide by 40, we have x equals 3/4. So our sentence can be, Tyler needs 3/4 a cc for his dose. Okay, for this week, we will have our biblical worldview. You will be discussing following Jesus and how our journey is not linear and what that means. In terms of my lab, we're covering 6.2, 6.3, 6.5, and 6.6 this week. Please make sure you are in the study plan doing practice problems for your exam coming up after we finish chapter 7.